Welcome to my presentation. This presentation is part of the playlist Integration by Substitution. In this presentation, we will be solving problems using integration by substitution method. So let us look at an example. In this example, we want to integrate 12x times 6x squared minus 1, the whole thing raised to the power of 3 dx. Okay, so we are going to use the integration by substitution to solve this example problem. Let us substitute u as equal to 6x squared minus 1, which is inside this parenthesis here, 6x squared minus 1. Differentiating u with respect to x, we have du by dx. The differential of 6x squared is 6 times 2x, which is 12x, and then the differential of negative 1 is 0. I didn't write that. So therefore, du by dx of 6x squared minus 1 translates to 12x, like that. So now I can write this as du is equal to 12x times dx. I brought this dx in the denominator to the side of this expression here, and then wrote it out as 12x times dx. I want to express it in terms of dx. Dx is equal to 1 over 12x times du. Now we can substitute u as equal to 6x squared minus 1 and then dx as equal to 1 over 12x du into the given example problem and solve it using the integration by substitution method. So our given example problem reads as follows: integral 12x open parenthesis 6x squared minus 1 close parenthesis the whole thing raised to the power of 3 dx. So wherever we see 6x squared minus 1, we're going to substitute it by u, and that's what we see here. So 12x remains the same. 6x squared minus 1, we substituting by u, and then to the power of 3, which is that. And then dx, we're going to write as 1 over 12x du, as shown here. Dx, we wanted to write it as 1 over 12x du. Now we have successfully substituted all the terms, and now we want to simplify it. So we have a 12x in the numerator, 12x in the denominator. Those cancel out. We are left with y is equal to integral u cubed du, like that. Okay, so now we are ready to apply the process of integration. So integral u cubed we can write as u to the power of 3 plus 1, the whole thing divided by 3 plus 1, plus c, where c is a constant of integration. And then when we simplify this some more, u to the power of 3 plus 1 translates to u to the power of 4. And in the denominator, we have 3 plus 1, which translates to 4 plus c. So now we want to back substitute u as equal to 6x squared minus 1. We cannot leave the solution in terms of u. We need to have the solution in terms of x. So for our simplification's sake, we substituted u as equal to 6x squared minus 1. And then once we reach this stage here, we're going to substitute u as equal to 6x squared minus 1. And in this step, you'll see that we can write it as 1 over 2, 1 over 4, open parenthesis. Instead of u, we're going to write 6x squared minus 1, the whole thing raised to the power of 4 plus c, where c is a constant of integration. So this is the way we want to solve example problems using integration by substitution method. So let's look at another example. Let's say we want to evaluate this integral x squared open parenthesis 2 minus 3x cubed, the whole thing raised to the power of 3 over 2 dx, like that. We are going to use the integration by substitution to solve this example problem. Let us substitute u as equal to whatever we have inside this parenthesis here, 2 minus 3x cubed, like that. U is equal to 2 minus 3x cubed. We want to differentiate u with respect to x. U is a function of x, so we're going to differentiate this function with respect to x. Du by dx is equal to the differential of 2, which is a constant, is 0. I did not write that. The differential of minus 3x cubed is going to be equal to 3 times 3 is 9, x to the power of 3 minus 1, which is 2. So minus 9x squared is what we are left with. So I can write du as equal to minus 9x squared dx. The dx comes to the side of the expression here. And therefore, if I want to express it in terms of dx, I can write this one as minus 1 over 9x squared du. Now we can substitute u as equal to 2 minus 3x cubed and then dx as minus 1 over 9x squared du into the given example problem and solve it using integration by substitution method. So the given problem we have is x squared times 2 minus 3x cubed, the whole thing raised to the power of 3 over 2 dx. So wherever we see 2 minus 3x cubed, we're going to replace that by u as shown here. So therefore, we have integral x squared, which is the same. 2 minus 3x cubed, I'm going to replace that by u, and then that is raised to the power of 3 over 2, and therefore u to the power of 3 over 2. And then instead of dx, I can write minus 1 over 9x squared du, like that, minus 1 over 9x squared du. So now we're going to simplify it some more. So as you can see here, minus 1 over 9 is a constant, so we can write it outside of the integration process. And then x squared is in the numerator, x squared is in the denominator. Those terms cancel out, leaving us with u to the power of 3 over 2 du. So therefore, now we are ready to apply the process of integration. So integral u to the power of 3 over 2 du, we can when we apply the process of integration, we can write it out as shown here, minus 1 over 9, which is a constant. Then nothing happens there. Integral u to the power of 3 over 2, we can write as u to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 plus c, where c is a constant of integration. So let's simplify it some more. Minus 1 over 9, u to the power of 3 over 2 plus 1 is 5 over 2, right? Divided by 3 over 2 plus 1 also is 5 over 2 plus c. Now let us simplify it some more. Minus 1 over 9, we have 5 over 2 in the denominator. When we bring it to the side of the expression, it translates to 2 over 5 times u to the power of 5 over 2 plus c. Now when we have some constant terms here, minus 1 times 2 is 2, 9 times 5 is 45, and that becomes minus 2 over 45 times u to the power of 5 over 2 plus c. Now we need to substitute back u as equal to 2 minus 3x cubed. Wherever we see u, we will substitute that. Therefore, in this next step, you will see that minus 2 over 45, instead of u, we're going to write 2 minus 3x cubed, like that. The whole thing raised to the power of 5 over 2 plus c, where c is a constant of integration. So this is the way we're going to solve example problems using integration by substitution. In my next video presentation, we will be solving more example problems related to integration by substitution.